After that, question number 66. Which among the following is not a conjugate acid-base pair? So first thing you should know that suppose you have an acid, there should be its conjugate base, and that can be formed by removal of the proton from it. So if I talk about this acid A, and if you remove a proton from this A, then you will obtain its conjugate base. Now similarly, if I talk about a base, and suppose it's conjugate acid you need to find, then what you will do for the base, suppose this is B, and in that base B, if you add some proton, then it will be the conjugate acid of that base. So if I talk about H2O, H2O is here as an acid and it is losing a proton to form OH negative. It means it's conjugate base. So this is the conjugate acid base pair. Further, SO4 2 negative. In this case, there is no H plus ion, but on taking H plus ion, it means if it is acting as a base, it will take H plus ion and then it form HSO4 negative. But this is not correctly given here. It is given H2SO4. So this is not the conjugate acid base pair. Further, let's check the next one also, H3PO4. And after removal of a proton, it will form H2PO4 negative. This is also conjugate acid base pair. Further, H2CO3. After losing proton, it will form HCO3 negative. So in this case, it is representing conjugate acid base pair, but the second one is not showing, so that's why I just choose option 2 as the correct option. After that, there's another question. Question number 67. Solubility of AgCl in 0.1 molar CaCl2 solution will be. You should always know that solubility is equals to the Ksp value divided by the molarity of common ion. In this case, the common ion is chloride ion. Just have a look. We have AgCl and CaCl2. Chloride ion is the common ion. So its solubility would be equal to Ksp value that's given 1.8 into 10 raised to the power minus 10 for AgCl divided by molarity of the common ion. If the molarity of calcium chloride is 0.1, then definitely the molarity of chloride ion in this case would become 0.1 into 2 because 2 chloride ions are there. So it would be 0.1 into 2. Now this can be written as 9 into 10 raised to the power minus 10. And yes, it is correct answer. That's given here in option 2. Now question number 68. Incorrect statement among the following is H3PO2 contains 1 POH bond and 2 pH bonds. Further, H3PO3 contains 2 POH bonds and 1 pH bond. H4P2O6 contains 3 POH bond and 1 pH bond. And further, H4P2O5 contains 2 POH bond and 2 pH bond. It means you need to just have a look on the structures of oxo acids of phosphorus. So in this case, I have the structures for you. H3PO2, I have the structure H3PO2. In this case, 1 POH bond, you can clearly see this is 1 POH bond and 2 pH bonds. Yes, it means option 1 is showing the correct statement, but you need to find out the incorrect statement among the following. So next is H3PO3. Another structure we have H3PO3, you can clearly see, and in this case 2 POH bonds are present and 1 pH bond is there. It means this is also statement that's correct. Further, H4P2O6. We have the structure of this H4P2O6 here, and in this structure there is 3 POH bond. Just have a look. POH bond? No, there are 4 POH bonds. As well as if I talk about pH bond, there is no pH bond. It means this is the statement which is incorrectly given here. Further, H4P2O5. This is H4P2O5. In this case, as per the statement, 2 pH bonds. Yes, 1 pH bond is this, 1 pH bond is this, and 2 pH bonds. pH bonds are also there. These are 2 also. So this is the correct one. So which statement is incorrect? Definitely statement 3 is incorrect statement, and that we will choose our correct option. After that, Question number 69. The product which is not formed by the reaction of AgNO3 with hypophosphorus acid is. In this case, we need to just write the reaction that is taking place in this case. So we have the reaction in which we have AgNO3 reacting with aqueous. AgNO3 is reacting. That's why water is also there. And it is reacting with hypophosphorus acid. So that is H3PO2. So here is, I'm just balancing it also. Now here's the formation of Ag. Along with that, HNO3 is also formed, and there is the formation of H3PO4, hypophosphoric acid, that would be formed. So this is the reaction. Now let's check the products given here in the options. NO2. You cannot find NO2 here. It means NO2 is not formed. But Ag is formed, HNO3 is also formed, and H3PO4 is also formed. It means the correct option that is showing the product that's not formed during the reaction of aqueous AgNO3 with hypophosphorus acid is option 1. Let's take next question.